starts talking about on page 194. And got a little whaling video to show y'all. Are you recording that?
Mm-hmm.
Can you pull the black blinds open? It's a little dark in here. I want to get a little more light. That's it. And maybe this one right here too. Okay, very nice. Yes. All right, so whaling is hunting whales. And it was big in the mid-1800s. As soon as they invented steamships and harpoons, they could easily catch lots of whales. And since a whale is such a huge animal, then you can get a lot of stuff from it. You can get a lot of fat, a lot of oils. Whale oil was they used to use it to light lamps and stuff like that before, normal oil came around that you dig out of the ground. So it was a big source of that, big source of food. They still hunt whales in some places. Because whales are slow moving and slow to reproduce, the numbers decreased rapidly. The International Whaling Commission was made in 1946 to regulate the whaling industry. It's just like if you go out fishing, there's limits on everything. Do you know the limits on the fish that you fish, Trey?
Most of them.
Give me an example of one of the limits.
Like a trout's like 16 inches.
So, any bigger than 16, you can't.
You can't keep it any lower than that.
You can't keep it any lower than that. Gotcha. How about a number? Do they give you total numbers?
It's usually not a number. It
No.
shows like 20 or something.
Okay.
Like that.
It's high for. They put limits on these fish because if everybody goes out there and catches as many as they can, there won't be any more of them. The fish can reproduce, but you gotta give them a chance to do that. And the same thing with whales. So this International Whaling Commission, they would, regulate the industry, put limits, patrol, in order to keep enough whales out there so they don't go extinct. And then nobody gets any whales.
What that whale war showed.
Yeah. They do most of the whaling in the northern waters and cold waters, and it's a big industry in Japan. A lot of the whales are caught by accident. You see the dolphin there caught in a net. If you're dragging a net for shrimp or whatever, sometimes you get whales caught in the nets, and they can't escape and get all tangled up. And there's no way to devise a net that's not going to accidentally catch something. Pollution doesn't help the fish either, or the whales either. So there's all kinds of problems out there, and so the numbers go down and down. Some numbers have come back up since they've put them on endangered species lists. But this is about an 8-minute video on whaling. There's a significant slant to this because this is done by the people who want to stop the whaling. But it does have some good info in it. Oh wait, no, this is
Scenes like these, showing anti-whaling activists and Japanese ships sparring in the Southern Ocean, have taken place repeatedly in recent years. The killing of whales, whether it's called research or hunting, has remained a hugely charged and political issue. And nowhere more so than at meetings of the International Whaling Commission. At its meeting last year, delegates from Japan, Iceland and a number of other Caribbean and African nations walked out. they refused to vote on a proposal to create a whale sanctuary in the southern Atlantic Ocean. In 1979, the entire Indian Ocean, as far south as this, was made a whale sanctuary. In 1994, the Southern Ocean Sanctuary was added. It covered all the water up to here, except around South America, where the line was drawn a little further south. The proposed new sanctuary is designed to protect whales in the Atlantic from the equator south, including the entire southern Atlantic Ocean.
Their migratory corridor from the South Atlantic feeding grounds to their calving and breeding grounds in the tropical waters of the Atlantic, both on the African and South American coast, would really give the whales the protection throughout their entire life.
Japan, which has continued its so-called scientific fishing even in the southern sanctuary, has argued that any new sanctuary should be agreed to by consensus and not by a vote. The IWC's rules require a 3/4 majority to create a sanctuary.
It's a difficult hurdle to get to 3/4. This South Atlantic whale sanctuary proposal has 8 times been presented by the governments of Brazil and Argentina, 8 times secured an increasingly strong, simple majority vote, but not yet the 3/4 required. We're still counting noses and bums on seats here to see what the turnout of the conservation countries will be, and still working hard to encourage a more enlightened approach.
Conservationists say the new sanctuary would do more than just protect the 52 species of cetaceans or whales living in the area. It would also make plans to deal with threats including climate change and pollution, and encourage activities such as whale watching. In this way, the vote on the Southern Atlantic Sanctuary is being seen as a test of the IWC itself and of its future direction. Tarek Vasley, Al Jazeera.
That was a different video than the one I was thinking, but anyway, you can see what they're trying to do is make places for the whales to live without being hunted. The Marine Mammal Protection Act of 1972 banned hunting of marine mammals in U.S. waters and importation of products from other countries. So since 1972, it's been illegal to hunt any marine mammals. Dolphins, whales, sea otters, sea lions. You can't do it in U.S. waters. But that doesn't stop other countries. And so one thing we say that you can't do is import products from other countries. So you're not going to, they're not going to get our business, and that reduces the number of whales that they're trying to catch. So you're not going to find whale meat in grocery stores and such. Most whaling is stopped because whale numbers are so low it's not commercially viable. It's hard to make a living off this sort of thing because there's just not many out there. And some whale species numbers have gone up due to conservation efforts. So whale numbers went way down, and now you're starting to get a rebound. On page 193, table 9.2 in your book, which I have up here, shows some of the different whale species and their status, and how many they think are left out there. So the blue whale, that's the biggest one, that's endangered. There used to be about 200,000 of them maybe out there, and now there's 5,000 left. So this right here, estimated pre-exploitation numbers. That's how many there was before humans started hunting these things. And what's the one we have at calving ground just off our coast? Do you remember? Northern right whale. It's endangered too. There's only about 870 to 1,000 of those left. And that was in the early 2000s, so that was 10 years ago. So who knows what it is now? Maybe the next edition to this book they'll update it. The Atlantic gray whale is extinct. That means there's 0 of them. So which one of these has the lowest numbers right now? Western Pacific gray.
How can they know for sure it's extinct?
They don't. But if no one's seen one in a real long time, it's probably extinct. Because one thing you need to carry on a population is many organisms. 2 or 4 or so just won't work because their kids are having to mate with their kids, and that usually ends up getting so many mutations that the babies can't survive. So if your population gets down to just a handful, the species is doomed. So there might be a couple of them out there somewhere that nobody's happened to see, but they're as good as extinct. You know, they put on trackers and tracking devices and such to figure out where these things are. And so they can get a good idea of where they go each time of the year, where to look for these things, to try and get counts. But it's not a perfect science. After the discussion of whaling and such, it kind of just talks about, in this section starting page 197, where it says biology of marine mammals, it just talks about various things that all marine mammals have to do. Swimming, diving. There's a section on swimming, a section on diving. A section on echolocation. So it's just kind of general things about a section on behavior and reproduction. General things about marine mammals. So let's just talk about some of those things here, and I want you to make sure you do your reading. Seals and sea lions swim by moving their flippers back and forth. Whales and dolphins move their flukes up and down, so they have different ways of swimming. Seals and sea lions are using their flippers, you see, to push the water. And the whales move their tails. Whale breathing is done through the blowhole. The spout can be seen at great distances and can be used to identify the whales. Whale watchers have memorized all the blow patterns of all the different types of whales. So you don't even need to see the whale. You can just see the way the water spouts up when it breathes. And they have a table in the book showing all the different blow patterns on page 198. And then kind of what its back looks like and what its tail looks like as it comes out of the water. Oh, that shows a dolphin how it swims. Here we go. So each one, if it goes way up like that, it's a blue whale. And if it's just real short, it's a gray whale. A right whale has this double blow pattern. Those are the ones we have around here. Sperm whale goes kind of forward, and a humpback whale. So you could just figure out what it is from a distance. Anyone here ever been whale watching?
Yeah, but I didn't see any.
Really?
I saw one.
Go. We went whale watching when I was in Los Angeles one year. And they have whales. No, I'm sorry. It's Hawaii. Yeah, but you can see whales off the coast of Los Angeles.
We saw a couple in Mexico.
In Mexico? Do you remember what they were?
I made a song.
Yeah.
So much.
Y'all saw them last year? Where?
Mexico.
Oh. Did y'all both go to Mexico together?
Last year.
Was it a fishing trip? Just for fun? Sweet. Once the whale goes under, it can dive for a long time. Up to 6,000 feet deep. The deepest diver is the sperm whale. That's like a mile deep. And they have to hold their breath when they go down that deep. And some of them can hold their breath for an hour. Sperm whales maybe 2 or 3 hours holding their breath. So you wonder, how do they do this? Well, this chart kind of shows all the different adaptations that whales have for going deep and holding their breath. One of them is called apneustic breathing. Rapid deep breaths followed by an exhalation before the dive to increase oxygenation of blood and decrease air in the lungs to decrease buoyancy. Divers will do this. Do you learn this in diving? You go before you dive, and that gets a lot of oxygen in. And what they'll do is exhale. That just made me a little bit dizzy. They'll exhale they don't want, one thing about having a lot of air in your lungs is that it makes you float. And so they have an exhalation before they dive. They exhale, and it makes them able to dive deeper and faster. And what they've done when they take in a lot of breaths quickly like that is they increase the amount of oxygen that's in their blood to a very high level. So they don't need the oxygen sitting in their lungs. It gets in their blood. They get it out of their lungs, and then they can dive real deep and fast. They have a lot of red blood cells in their blood. You see it says more blood and higher concentration of erythrocytes. Those are blood cells to maximize oxygenation. So they got a lot of blood in their bodies. And if you look at just a drop of their blood, it's got way more blood cells than a drop of our blood. So it can carry more oxygen. Each blood cell has more hemoglobin than our blood does. And hemoglobin is the molecule that carries oxygen. So each blood cell of a whale can carry more oxygen than our blood cells can carry. And inside their muscles, they have a molecule called myoglobin. And myoglobin is also an oxygen-carrying molecule that's in their muscles. We have it in our muscles too, but they got a lot more of it. And so not only does the blood carry oxygen, the muscles carry oxygen. The muscles can, think of all the muscles in the body of a fish. If you eat fish meat, that's muscle. So there's a ton of muscles in their body, and all the muscles hold oxygen and can hold a lot of it. And they have this expandable rib cage that helps. They have bradycardia, which means they slow down their heart rate when they dive. So their heart is not beating as fast. And it helps them conserve oxygen. And they don't send as much blood to non-vital organs when they're diving. The blood goes to the brain. It goes to the organs where they need it, and the blood does not go to organs where they don't specifically need it at that time. For instance, like your digestive system uses a lot of blood. When these animals dive, they don't send any blood to their digestive system. They're not digesting any of their food because that takes a lot of blood and a lot of oxygen. So they just don't send any blood to their digestive system. And what they'll do is they'll dive deep, they'll catch their food, then they'll come up, and then they'll digest their food when they get to the surface, when they have plenty of oxygen around. So all these things help these animals dive. Another thing they talk about is they have ways of keeping nitrogen out of their blood. One problem with human divers is when you dive down deep and then you come up too fast. Have you ever heard of this? If you come up too fast when you're diving, what will happen to you? Have you ever heard of what it's called? What's that? You can have a bursting, but what's it called in the blood with the little bubbles that form? Y'all ever hear that? It's called the bends. If you come up too fast when you're diving, you get the bends because the nitrogen gas that's in your blood will expand and form bubbles. And so how does a whale come up so fast? They don't have nitrogen in their blood. They have ways of keeping the nitrogen out of their blood, special adaptations. So they don't get the bends very easily. The next section talks about echolocation. Whales, especially dolphins and porpoises, use a lot of echolocation. And other whales do too. Sperm whales do it a lot. And what they have in their head, if you've ever looked at a dolphin, it's got like this huge forehead. You ever notice that? It's a weird looking forehead. And what that's called the melon. M-E-L-O-N. And the melon contains kind of a gel-like substance in it. And they have these air sacs behind the melon that can vibrate and produce sound. And the vibrations go through this melon and are amplified by the material in there. And the sound comes out, and the melon can help direct the sound to the proper area. And so when the dolphin does this, it makes a series of clicks. They're called echolocation clicks. If you've ever heard a dolphin, you can hear it just click, 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 click.
One time I was scuba diving and we could hear dolphins underwater. You couldn't see them, but
you could hear them, yeah. Another thing about sound is it travels really well in the water. It travels a long way. You've probably been in a pool and dropped a penny and you can hear it click against the bottom. The sound really travels well through water, and so sound is a good way to communicate in the water. So these clicking sounds leave the whale and can be directed anywhere they want. They can spread it out wide. They can do it just kind of straight, and it'll hit objects. And the sound, after it hits the object, will bounce back, and the jaw of the whale collects the sound and is shaped in such a way that it'll send the echoes to the ear, which is actually kind of down here in the body. So the vibrations come through the jaw to the ear, and the whale can make sense of what's out there just by listening to these echoes. And it can even kind of draw a little picture in its head of what's out there. It can even figure out shapes and such. They've done experiments where they put things in a pool, like a chair in a pool, and they turn out all the lights. You see, so there's no light, and whales can navigate around these objects just using echolocation. And they can even talk to other whales by using these echolocations. They can, for instance, in one experiment, they had some food, and they put the food in one kind of like a treasure chest inside a pool. And then they had this other container that was shaped differently, like it was shaped like a cylinder or something. And the food wasn't in it. And they showed this one dolphin, they let it watch where it put the food. And then they sent that dolphin back. And that dolphin made these clicking sounds to the other dolphins that were in this other pool with it. And when they came in, they know to go directly to the treasure chest, not to the other one to get the food. So they're able to communicate. And what scientists think that they're doing is they're echoing, they're making clicks that exactly copy the echo you would receive if you sent clicks out toward the treasure chest, you see. They send clicks out towards the treasure chest and get these echoes back of the shape of a treasure chest. And then you go to your buddies in the next tank and you send out the echoes that tell them the shape of the treasure chest. You see? And then they can go back to this pool and send out echoes, and when they get that treasure chest, they know that's where to go. How cool is that?
Do they have eyes?
They do have eyes. But if you turn the lights out in the pool, then they can't use that vision. So it's amazing. They're smart and they can communicate really well in a way that we don't even know about. Did you ever watch the movie Daredevil?
Yep.
He could do that. He had echolocation.
India, the Ganges. It isn't salty, but it's just about everything else. It's certainly muddy, with only a few inches of visibility. And the dolphins here don't have any lenses on their eyes at all, and can probably just see light and dark. So how does the Ganges dolphin find its way around? How does it find the fish that it eats? It relies almost exclusively on the sense that all cetaceans are masters of: echolocation, sonar. Its entire head is built around an array of sending and receiving equipment. The dolphin makes clicks near its blowhole, and then, in a fat-filled cavity in its forehead called a melon, the sound is guided into a narrow beam. Sound is sent out as a series of short pulses. The echoes that are reflected back are heard through the dolphin's lower jaw, which is connected to the ears. It's as good as vision. In some ways, better. Dolphins can see things that can't be seen. Dave Goodson is from the Underwater Acoustics Group at Loughborough University in England.
We're looking at the dolphin sonar, and just to put it into perspective, a bottlenose dolphin can see something the size of an orange about 80 meters ahead of him. And that is approximately equivalent to the echo it would get from quite a large fish, but one that it could still swallow whole. So we've got a good feel, I think, for what they do in the wild, looking for fish mid-water. But then we discovered the interesting thing. It was like the dolphin who is looking into the seabed surface at close range and clearly has detected the presence of a fish that's buried in the sand. Now, the echoes at the frequencies they produce should bounce from the sand, but they're able to get some information from below the sand particles, and they will sometimes even dive into the sand to recover them.
dolphin sonar seems sophisticated, it's because the animals have had 20 million years to adapt and perfect it.
How cool is that? Now, a sperm whale has this huge organ in its head. It's called the Spermaceti Organ. And it's basically the melon. The reason why they call it sperm whale is because when they stab this whale with a harpoon or something, all the fat stuff that's in its melon, that's in its Spermaceti organ, would leak out. It looks like sperm. So they called it a sperm whale, you see. But it's just the fatty, gooey stuff that's in the melon. And so the Spermaceti organ of a whale is basically the melon. And you can see how huge it is. They have real good echolocation. And scientists think what the sperm whale does is it dives down deep, and when it sees a squid or something, it gets close to it, and it makes this huge loud sound. Because of this giant Spermaceti organ can focus all the sound waves that it produces and kind of put them all on top of each other, so this real loud sound is produced that knocks out the squid. Can you imagine how loud it must be if you get knocked out by the sound? And then it's able to stun it, for a minute. Boom! And then grab it. The squid is just like, whoa. It's dead. You often find whales in groups or pods. And there we have a bunch of them. And the pods, there's a lot of, reasons for living in a group, just like when fish school. It's easier to find a mate. Sometimes it's easier to hunt. And I'll show you, this next video shows a bunch of hunting dolphins working together in a pod. And you can defend yourself sometimes better if something's coming to eat you. If you got a bunch of you, then it might back off. So, I thought I had a video. Hold on. Yeah, this is the one I want to show you. These are videos. This is a video of group feeding.
May be home to 30 million different kinds of animals and plants, each individual locked in its own lifelong fight for survival. Everywhere you look, on land or in the ocean, there are extraordinary examples of the lengths living things go to stay alive. This is the coast of Florida. Here, strange scars on the seabed hint at one animal's remarkable strategy. These are bottlenose dolphins, one of the most intelligent animals on Earth. Their prey is very elusive, fast-swimming fish. But the dolphins have invented a completely new way of hunting. By beating its tail down hard, this dolphin stirs up the shallow silt. And by swimming in a tight circle, it creates a ring of mushrooming mud around a shoal of fish.
just like a net. Panicked, the fish jump to escape. Right into the open mouths of the waiting dolphins. Again and again, the lead dolphin creates a circle before they all line up with perfect timing. These dolphins are the only ones known to have developed this hunting behavior, and it gives them an edge. This sort of advantage may mean the difference between life and death in the survival of the fittest. This series reveals the most spectacular and extraordinary strategies that animals and plants have developed.
That's a great series, by the way. Have you ever seen it? It's called Life. It's like a high definition series if you have an HD TV. It's pretty cool stuff. All right, so the next section, this section continues on the behavior of marine mammals. They're known for vocalizations, such as barking of sea lions, humpback whale songs. There are scientists right now just studying the songs of humpback whales and what they mean. Humpback whales each sing a different song, and they have different songs at different times of the year. And next to primates, which are monkeys, apes, and humans, we think whales are probably the smartest other mammal. And so their sounds probably mean something. They're probably not just, like the barking of a dog. Although barking of a dog, they do have different barks for different meanings. But it might be a language where they're actually talking to one another, these humpback whale songs. I have a recording of it down here I'll play for you. So they have different songs, some for mating, some for just communicating, some for distinguishing individuals. This is, that's so-and-so, that's her song, so you know who that is. And this is, here comes so-and-so, I know that song. It's kind of like how dogs use smell to figure out who's who. That these whales and all other types of marine mammals use sound. And again, it's good to use sound in water because sound travels so fast and so far in water. As a matter of fact, whale sounds can be heard all the way across an ocean. 2,000 miles a whale sound can travel. And so they keep good track of where one another is in the ocean. They have real good hearing, and sound travels real fast through the water. A lot faster than it does in the air. They've also noticed that marine mammals will play just like kids play. They don't have a reason for some of their behaviors. They're just going around playing with things. And you see play in all intelligent organisms. Organisms that have a very high intelligence all play. And it's a way to practice doing some of the movements and such that you'll need to survive. And obviously the whales, when they're playing, they're having fun. You can just tell by the way they act.